Hello, my name is Stephen Hendry and I am the Royal Society of Chemistry Education Coordinator for the West of Scotland. In this session, we will be exploring the impact of the current climate emergency under the overarching theme of COP26 to encourage sustainable learning within your classroom. The presentation, resources and references to all content discussed will be freely available via the link to the Padlet in the description below. You will see teacher comments in the Padlet and you're encouraged to continue the discussion with how you would use these resources in your own classroom. If you have any questions, then you are more than welcome to get in touch with me directly at the following contact details. The climate emergency session has been developed to discuss the implications and possible solutions to the climate emergency on both a local and global scale. Alongside easily accessible but effective support and practicals to visualise and engage. This also intends to support collegiate working and highlight the importance of cross-curricular working and discussions. In this session, I will provide a mixture of ready-to-use resources that can be used immediately in the classroom, as well as climate emergency practicals that have been developed to be accessible and low hazard for both primary and secondary teaching. The practicals come with links to integrated instructions and discussion topics that will have a positive impact on your students' learning. I hope that by the end of the session, your confidence and knowledge for implementing current climate emergency research, practicals and current pathways into your classroom and across your department will have improved. We are already seeing the effects of climate emergency with increasing number of extreme weather events and exacerbating air pollution. Pupils are acutely aware of environmental, political and socio-economical problems that societies face today. They have demanded urgent action on a global scale with School Strike for Climate and have become engaged with Greta Thunberg's activism, often cited as a diverse role model that is key for widening access and inclusion. Furthermore, the next generation are more inclined to choose a career that addresses these global concerns. For nearly 3 decades, the UN has been bringing together almost every country on Earth for global climate summits. In that time, the climate emergency has gone from being a fringe issue to a global priority. This year will be the 26th annual summit, giving it the name COP26. In the run-up to COP26, the UK is working with every nation to reach an agreement on how to tackle the climate emergency. More than 190 world leaders will arrive in Scotland, and joining them will be tens of thousands of negotiators, government representatives, businesses and citizens for 12 days of talks. Under the Paris Agreement, every country agreed to work together to limit global warming to well below 2 degrees and aiming for 1.5 degrees, to adapt to the impacts of a changing climate, and to make money available to deliver on these aims. The aim for 1.5 degree reduction is important because every fraction of a degree of warming will result in the loss of many more lives and livelihoods. Under the Paris Agreement, countries agreed that every 5 years they would come back with an updated plan that would reflect their highest possible ambition at that time. At COP26, countries will reflect on the impact of the Paris Agreement and make plans to tackle the climate emergency moving forward. Greenhouse gases naturally occur in Earth's atmosphere. In fact, the most abundant greenhouse gas in the atmosphere is water vapour. Without greenhouse gases, the global temperature would be around 30 degrees Celsius lower than it is today. However, human activity is increasing the concentration of greenhouse gases in our atmosphere. This has resulted in less heat escaping into space and consequently an increase in temperature on planet Earth, known as global warming. The idea that greenhouse gases warm the planet is anything but new. In 1856, Eunice Newton Foote published her paper about circumstances affecting the heat of the sun's rays. She wrote that a cylinder with moist air became warmer than one with dry air, while a cylinder filled with carbon dioxide warmed even more, and once removed from the light, it was many times as long in cooling. In 1859, Irish scientist John Tyndall began studying the ability of gases like water vapour, carbon dioxide, ozone, hydrocarbons to absorb and transmit radiant heat. In 1896, Swedish scientist Savant August Arrhenius said any doubling of the percentage of carbon dioxide in the air would raise the temperature of the Earth's surface by 4 degrees Celsius. This was followed by Scottish scientist Alexander Graham Bell, who in 1917 wrote that unchecked burning of fossil fuels would have a sort of greenhouse effect. The net result is the greenhouse becomes a sort of hothouse, and proposed the use of alternative energy forms such as solar. The effects of the climate emergency can be seen both locally and globally. By looking at climate data, we can see the changes to our climate, and with projections, we can see that the climate is expected to change to become hotter, wetter, with more extreme weather conditions. The Keeling curve is a graph of the accumulation of carbon dioxide in the Earth's atmosphere. These readings are based on continuous measurements taken at an observatory on the island of Hawaii, and they show an increase in the monthly mean carbon dioxide concentrations from 1958 to the present day. To put this into a local perspective, in 2019, carbon dioxide accounted for 70.2% of Scotland's greenhouse gases emissions. The Show Your Stripes has been designed by Professor Ed Hawkins at the University of Reading to illustrate rising global temperatures and spark conversations and action around the climate crisis. These warming stripe graphics are visual representations of the change in temperature as measured over the past 100 years. Each stripe represents the temperature averaged over a year. For virtually every country, the stripes turn from mainly blue to mainly red in more recent years. This illustrates the rise in average temperatures across our planet. An increase in carbon dioxide levels leads to an increase in global temperatures, which in turn results in a rise in sea level. Sea level rise is caused primarily by two factors related to global warming: the added water from melting ice sheets and glaciers, and the expansion of seawater as it warms. One of the biggest resulting threats to cities around the world is sea level rise. Projections of sea level rises indicate that 3 million people would be affected in Egypt, 2.7 million people in Miami, 5.2 million people in Japan, and 17.5 million people affected in China. Scientists at the non-profit organisation Climate Central estimate that as a result of heat trap and pollution from human activities, rising sea levels could within 3 decades push chronic floods higher than land currently home to 300 million people. By 2100, areas now home to 200 million people could fall permanently below the high tide line. In the past decade, the global refugee population has more than doubled. More than 26 million refugees currently live in host countries, many of which are in neighbouring countries. We are now at the highest population on record, with 68% of the world's refugee population coming from just 5 countries. 1% of humanity has been displaced, with fewer and fewer able to return home. 40% of those were children under the ages of 18, and 85% of those are being hosted in developing countries. At least 100 million people have been displaced between 2010 and 2019. Millions of people live in refugee camps. These are temporary facilities built to respond to specific emergencies, providing immediate protection and assistance to people forced to flee. However, as these situations become protracted, many refugees find themselves living in refugee camps for years or even decades. This highlights the importance of not treating the climate emergency as only a scientific issue, but to consider the ethical, legal, and moral impacts, and integrating the topic of climate justice into your classroom teaching, with discussion topics around the impact of the climate emergency on the most vulnerable people living in the world's poorest countries. Looking at greenhouse gases, So we could look at some activities to try out in our classroom. This activity looks at the main gases responsible for the greenhouse effect, and they include the carbon dioxide, methane, nitrous oxide, water vapour, and our fluorinated gases. In this session, you would set it up by asking the pupils whether they had any prior knowledge on these gases, and then begin comparing and contrasting how long the gas stays in the atmosphere, how effective it is, the concentration of gas, etc. The next stage would be to look at where these gases originate from. So the burning of coal, gas and oil, all fossil fuels which contain carbon, would release carbon dioxide. Livestock release the methane gas through their burping. Crop fertilizers, many of these will contain nitrogen compounds. And finally, our hydrofluorocarbons replace the ozone depleting CFC gases, but the hydrofluorocarbons, or our F gases, are widespread in aerosols and refrigeration. Using these additional activities, you could look at the properties of gases and how you can use these to distinguish between other gases. To understand and contextualize the properties of carbon dioxide, you could also ask your pupils to search for news stories and apply their scientific knowledge. This is an example in 1986 in Lake Nyos in Cameroon. Almost 1,800 people died overnight and 3,500 cattle were wiped out. This was triggered by the release of carbon dioxide. The gas cloud of carbon dioxide was given out from an eruption, and the carbon dioxide rose almost 100 kilometers per hour, and then being heavier than the air, descended onto the nearby villages. The carbon dioxide displaced all of the air and suffocated the people and livestock within 25 kilometers of the lake. Another news story taken from the BBC is looking at 3 people that had died at a dry ice incident at a Moscow pool party. What had happened here was dry ice was poured into a swimming pool to try and cool the guests down. However, dry ice is a solid form of carbon dioxide, and if it is released in an area without proper ventilation, it can cause people to inhale dangerous amounts of the carbon dioxide, which is unfortunately what happened at this party. You can then move on to demonstrate the properties of carbon dioxide using these simple practicals and demonstrations to teach your students about gases. These videos come with step-by-step instructions and delivery for both the primary and secondary classroom. I have also included links to integrated instructions, and the integrated instructions are very popular because they aim to reduce the cognitive load on students during the practical session, and they also support all pupils in the classroom as well. You could also compare gases by demonstrating the depletion of oxygen versus the production of carbon dioxide to extinguish a candle. If we look at pictures 1, 2, and 3, you can see that we have 2 candles, a smaller candle and a taller candle. In picture 2, we put a jar over these candles, and what we start to see is we see the oxygen depleting from top to bottom, and therefore the taller candle goes out first, followed by the smaller candle. We could then turn the container around and then add sodium bicarbonate and citric acid and then some drops of water to create carbon dioxide. In this case, the carbon dioxide is produced at the bottom and starts to rise up the container. The bottom candle goes out first, followed by the taller candle. Following on from this, you could look at some common misconceptions around the consumption of oxygen and water being sucked up into the jar. Looking at pictures 4 and 5, we're looking at 2 candles, again, 2 different sizes, but they can be the same size if required. But what we do here, we put the jar on top, and again, the oxygen is depleted and the candles are put out. At first, the flame heats the air inside the container, and this hot air expands very quickly. You might see some of the air escaping underneath the container with some bubbles coming out in the water around it. When the flame fades out and goes out, the air in the container cools and the cooler air contracts to take up less space. That contraction creates a weak vacuum in the container. This creates a pressure difference between the air inside the container and outside the container. And this pressure difference is what causes the water to be pushed up into the container. I personally like using the citric acid and sodium bicarbonate chemical reaction to create carbon dioxide because you can use it for 3 different experiments. We could have our fire extinguisher that we spoke about earlier, but we could also use the sodium bicarbonate and citric acid to make sherbet, or we could use the sodium bicarbonate and citric acid to make our bath bombs. In both of these experiments, the sodium bicarbonate and citric acid react to form carbon dioxide. The sherbet, you feel the fizzing in your mouth as the carbon dioxide being given off. And with bath bombs, when you put them into our bath and they start to fizz, is again the carbon dioxide being given off. You could also use this to introduce the themes of terpenes and smells, which again makes this an engaging practical due to the sensory aspect and the make and take nature of these experiments. This could hopefully embed the science and make it easier for your students to remember later on. Measuring carbon dioxide. So in this experiment, we are looking at how do we calculate how much carbon dioxide has been produced. Again, we have the integrated instructions here to show the step-by-step procedure. Initially, we get a measuring cylinder and we fill it with water. We turn it upside down and we make sure that the lip of the measuring cylinder is below the water. We then produce carbon dioxide. Again, here we're using a flask with tubing attached to it, but you could make your own if you got a 500 ml bottle of Coke, for example, put a hole in the top and then put the tubing coming through the lid. Make sure that it's sealed so that none of the gas escapes, and it would work the same way. The tubing I picked up from a DIY store for a couple of £2 for a couple of meters. So once we produce the carbon dioxide, we place the tubing underneath the measuring cylinder. The carbon dioxide then displaces the water, and using the scale on the side of the measuring cylinder, we're able to calculate or measure how much carbon dioxide has been given off. Generating and collecting gases is very useful because it gives us strong links to collecting data, and it also gives us strong links to plotting graphs and interpreting the data. This experiment could be replicated with Mentos mints or fizzy juice, and then if we keep the fizzy juice liquid constant and we add additional mints, we could represent the additional mints could represent the number of cars on the road or the number of factories burning fossil fuels and the amount of carbon dioxide given off. Again, you could change the mixture of citric acid and sodium bicarbonate to see how much carbon dioxide is being given off. And you could look at it from a balanced equation point of view, or you could plot it on the graph to see if there's any relationships. You could also extend this to compare the solids and gases dissolved in tap water and seawater. So what happens when carbon dioxide is produced? So following in the footsteps of Eunice Newton-Foote, early experiments into carbon dioxide, you could create your own artificial atmosphere. In this case, we have 2 containers with a thermometer in each. In one of the containers, we fill it up with carbon dioxide, and then we close it over, making sure that the carbon dioxide can't escape. We place these 2 containers next to a window or next to a bright light, and we look at the initial temperature, and then we look at what happens to the temperature over time. Hopefully what you should see is the carbon dioxide starts to hold on to the heat that's coming in, and therefore the jar with the carbon dioxide should start to see the temperature increase, whereas the jar with the air, the temperature should remain fairly constant. One of the ocean's largest roles is to soak up energy in the form of heat and then distribute it more evenly throughout the Earth. This is known as the global ocean conveyor belt, and we can demonstrate this experiment with a balloon. So here we have a candle and we blow up the balloon with air and then we place it over the candle. What you see very quickly is the balloon bursts. We then fill up a balloon with water and then we ask our pupils, what do you expect to happen? And what happens here is the heat energy from the flame in the form of heat is absorbed by the water in the balloon. This means that the balloon doesn't burst, and similar to our oceans, this demonstrates how our oceans absorbs heat energy. If you look at the bottom of the balloon, you will also see a black mark starting to form, and that is the carbon that's starting to be deposited at the bottom of the balloon as well. You can then follow this up with your pupils and get them to explain what is happening and get them to discuss what this means for everyday life. As well as absorbing heat, our oceans also absorb carbon dioxide. When our oceans absorb carbon dioxide, the carbon dioxide changes to carbonic acid, which is a weak acid, and that reduces the pH of our oceans, leading to something called ocean acidification. Ocean acidification is the ongoing decrease in the pH value of the Earth's oceans, and this is caused by the uptake of carbon dioxide from the atmosphere, and this mainly comes as a result of burning fossil fuels. This is an infographic from Compound Interest that illustrates carbon dioxide and ocean acidification. These have been created by Andy Brunning, and there are many more graphics to explore everyday chemistry in more detail. Using red cabbage indicator, you can create your own low-cost pH indicator. In this experiment, students observe the colour changes that result from adding indicator solution to a variety of acidic, neutral and alkaline substances. They then use their observations to estimate the pH of each substance, determining its acidity or basic. Further still, this method also lends itself to investigate discussion and practice by evaluating the effectiveness of the indicator, looking at different variables, or comparing red cabbage indicator against other natural pH indicators. In the bottom two pictures, we have a small sort of microscale experiment. In this case, we have put drops of red cabbage indicator, and then on the bottom right-hand picture, we have put a couple of drops of sodium bicarbonate and citric acid, and then we add a couple of drops of water to that. That produces carbon dioxide, and then we enclose that by either putting a container or a cup over it, and the carbon dioxide that's produced starts to interact with the red cabbage indicator, and it starts to change the colour of the red cabbage indicator from the right to the left. It's also important to note that when we talk about ocean acidification in our oceans, because our oceans have salt water, there is a buffer, and therefore the pH doesn't fall as low as you would expect in normal water samples. So when we talk about our pH dropping, it is only dropping by a couple of points of pH. So it's going from about 8.3 down to about 7.4 of a pH, as opposed to it going into more acidic conditions. This activity allows you to explore simple ways to engage your students in chemistry lessons because you're only using a small quantity of chemical, and again, you're only using basic apparatus. We could explore our microscale activities in more detail, And we could look at ways to engage our students in chemistry lessons, again using only small quantities of chemicals. On the bottom right-hand corner, you can see a video, and this has a pH indicator in the middle. And to the right, we have sodium bicarbonate, and to the left, we are going to add some citric acid. And what you should start to see is a colour change. So on the left-hand side, we are getting this red purpley colour, and on the right-hand side, we are getting a green colour. And you see that these colours meet in the middle to form the different pH indicators. The key here is to really focus on the questioning, to raise the level of demand. So let the students see or do the experiment, which will be quite straightforward, but then ask them higher level or open-ended questions to discuss where this maybe fits into everyday life, and in this case, how this fits into ocean acidification. On these printed practical sheets, you can take a picture or a drawing, and you can either laminate it or place it inside a plastic pocket. Using droplets of different acids and alkalis placed on top, and then adding red cabbage indicator, we can change the colour and create our own art. This is a bit like painting by numbers, but with different pH droplets. This activity lends itself to the creative thought process, which is central to making sense of observations and practical work. This would also link with the chemistry of dyes and pigments used in everyday life. You can follow the Crocodile Chemist on Twitter as they make pictures out of droplets of chemicals. Now, at this stage, I would normally stop and give you time to reflect on the content shared and how you would implement this in your own classroom. But as this is a recorded session, I will just move on. However, you are able to comment into the Padlet. That will have a link in the description below. And what I want you to do if you're sharing any of your comments is to think, what year group would you use this for? What would be the topic or title of the lesson? Would this be a starter, main, home learning task, and why? And optional, how would you differentiate this resource for more able and for less able students? Again, you'll be able to use the Padlet, and the link of the Padlet is on the screen to share your discussions and see what other teachers are commenting on the activities. So when we talk about climate emergency, we have to think about the importance of contextualising it for our young people, but also to integrate the literacy and numeracy, these transferable skills. And this will mean that your teaching becomes more relevant and more helpful for your learners, where they can see where it applies to other areas. On the Royal Society of Chemistry website, we have our Climate Change and Sustainability Resources Hub. On here are free lesson plans, experiments, activities to explore how chemistry can help us tackle climate change and build a more sustainable future. All of these resources come with teacher handouts and are risk assessed and will be continually updated on the run up to COP26 and beyond. You could also look at our Education in Chemistry magazine or Education in Chemistry website. On here, these are articles and ideas to support your teaching practice, and they are written by teachers for teachers. So again, there's lots of really good tips there about pedagogy, literacy, numeracy, and chemistry, etc., and how to integrate these into your classroom. So lots of really good tips to look for on there. We also have articles looking at current climate emergency research. So here we're looking at carbon dioxide getting stoned, so carbon dioxide getting captured in stones. And then on the right here, we're looking at using volcanic ash to seed the ocean and to try and absorb some of that carbon dioxide. So these articles come from cutting edge research, but they've been adapted to be used in the teaching classroom. Again, We could look through some of our numeracy articles, because when we talk about climate emergency, we have to talk about the projections, the numbers, the graphs, and what this means. So here are some ideas for integrating numeracy to make sure that it's suitable for all of your students. So here on the bottom left, obviously we've spoke about the temperature, the increase in temperature with our show your stripes, and it shows the importance of maybe using colour on thermometers to add to the scale and to help students grasp these relative quantities. We could also look at the data representation. So once we have data, what is the best way to present it? Do we use a graph, table? What types of charts would we be using? And again, we could try and teach our pupils how to choose the right graph when presenting their data. And again, getting them to think about why certain graphs have been chosen to represent projections in terms of climate emergency. On our education and chemistry website as well, we have our 7 simple rules for teaching science. This is the 7 recommendations that I have taken from the Education Endowment Foundation. And these are the 7 recommendations for improving science in secondary schools. However, they still apply for primary science because it is all good practice. All of these come with their own articles. So each of the rules come with a series of articles written by teachers for teachers, again, to use in your own classroom. Looking at this, we could be looking at the preconceptions. We could look at how we use debate to start to encourage these scientific discussions within your classroom. And again, here's 2 resources that you could look at, looking at the climate change and global warming, or the human activity and climate change. What do your students know, and supporting that self-regulation by letting the pupils direct their own learning? And again, we've got 3 resources here that you can use in your classroom. Again, when we talk about climate emergency, we have models, we have data and predictions. What does this mean? How can we understand it? And again, we've got 2 resources here, looking at data from the past and looking at the data temperature changes and how we can look at that data to make projections. The Wellcome Trust, they released their Tracking Public Views on Science, Biomedical Research and Science Education survey. And what's come out of this is quite interesting, that people like to hear from scientists. And again, this applies to your own pupils as well. So at the top, 73% of respondents said that they had the current or current latest findings from scientific research. They wanted to know more. And 57% thought that scientific research was relevant to them and their everyday life. When they asked, why did you pursue a job in the scientific or medical field, the number 1 reason was the enjoyment, that role and interest in the area. So by using topics like climate emergency that are linked to their everyday life, we can show these students how they can make a difference in the world that they live, and we can increase their interest and engagement in the area of science. You can also look at our Chemistry World magazine. Again, you can log on to our website to see all of these articles for free. The Chemistry World magazine addresses current events in the world of chemistry, including research, international business news, and government policy as it affects the chemical science community. And this is a great source for integrating cutting-edge research into your own classroom teaching. So it could be that you ask the pupils to go and read up some of these articles, or as a teacher, you could maybe go and look at some of these articles and bring them in to start off a session to talk about the chemistry being used all around us. Again, just reflecting on the importance of science. So this comes from the Public Attitudes to Science 2019, and this was looking at the UK public's attitudes to science, scientists, and science policy. So when they were asked, how important do you think each of the following subjects are in terms of helping young people obtain skills for the future, you can see that the majority said essential, very important, or fairly important for science, for the physics, chemistry, and biology. So they know that there's an importance there, and these skills and knowledge are important. The next question was looking at the perceptions of science and its impact on the economy. And again, very positive that a lot of people agreed that science has a very important role to play on society and our economy. Again, looking at this survey, they asked what attracts people to STEM careers. So that's the science, technology, engineering, and maths careers. And again, that top answer was interesting and stimulating. But they were also looking for jobs that are well paid. So again, a career that is stable and something that they can develop in. And for careers, you can look on our Future in Chemistry Making a Difference website. This is our award-winning Making the Difference campaign, and it's been developed to engage today's teenager, a generation who are highly motivated by the issues faced in the world and more determined than ever to impact on them. We know that this group are ambitious for a career that is driven by cause, wanting to make a difference to the world in which they live, both locally and globally. And through this new campaign with the job profiles, the employability skills and what jobs they can do, we hope to show that studying chemistry can lead to just such a career, whether that means tackling climate change, improving technology, or improving or contributing to medical advances. All of our job profiles are linked to the chemistry curriculum across the UK and Ireland with employability skills and what jobs can they do. This information about what students can expect to earn in the chemical sciences is something that comes back very positive from teachers. We also have career presentations, interactive games, career activities where chemistry can take you outside the classroom. And all of this information is suitable for parents, teachers, career advisors, and the pupils themselves. Now, just to finish off, just to put it into perspective, where are we with the climate emergency and what do scientists say? So we know that the majority of scientists agree that climate warming trends are extremely likely due to human activity. So that's with 97% of scientists agreeing. However, we have the politicians.
We have the cleanest air now in the world. We have the cleanest water. You're like this. We withdrew the United States from the job-killing, income-killing Paris Climate Accord. That was costing our country. And we have the cleanest air now in the world. We have the cleanest water. Remember this. I'm an environmentalist. I want crystal clean water. I want crystal clean air. That's what we want. But I also want jobs to come to our country.
So that was a speech that was delivered by President Donald Trump back in 2018. And in it, he had said that he was removing America from the Paris Agreement that we spoke about earlier. As you see, he said that they had the cleanest air and cleanest water in the world. A couple of weeks after this speech was given, the 2018 Environmental Performance Index was released. And this shows that America weren't even in the top 10 of cleanest countries across the world. USA was in fact in 27th place. And instead, it's important to note that these top places were dominated by European Union nations, all of whom remain part of the Paris Agreement. So it shows the importance of the Paris Agreement, this legislation, this policy, and to put it in place and the impact that it has been having. Again, it also is an opportunity for you to ask more of your politicians and to always question, always ask why. This here leads us on to the Veracity Index, and this is the trustworthiness of different professions from 2020. And as you can see, in 4th and 7th place are teachers with 85% trustworthiness and scientists with 82% trustworthiness. Again, if we look at the very bottom, 15% of the people surveyed thought that the politicians were trustworthy, so very low trustworthiness. And this just emphasises the role of scientists and teachers to make sure that there's nothing more important than that fair test. And how do we know that the results that we have are accurate? It's also important to give our pupils the skills and knowledge to go out and make an informed decision. And that will hopefully lead them to a career that will help make a difference in the world that they live in. We also want to be educating and helping our students to recognise fake news sources. So with the example of Donald Trump, looking at the statements that are being given and then comparing that to the scientific data or to the data that's available. And again, it's important to note that disagreement is the fuel between scientists. It helps develop these robust ideas and it comes to more accurate conclusions. So you should always encourage your pupils to continue to ask questions. Finally, what do all of these movies have in common? And the answer is at the start of the movie, the scientists were being ignored. And that's why with the run up to COP26 and the legacy after COP26, it's important to listen to the information, listen to the data, to fact check it, make your own informed decision, asking the questions, and make sure that the message is not being ignored. Thank you very much for listening to this session. So as I say, my name is Stephen. I am at the top left-hand corner of your picture there, and I cover the west of Scotland. For the north and east of Scotland, my colleague Laura Alexandra Smith is there, but for the rest of the UK and Ireland, you will all have a local education coordinator. And what's really good with this whole team is that this team has a range of expertise from primary, secondary, environmental scientists, food scientists. And so we are happy to share our knowledge and support any sessions that we can deliver to help you deliver a high quality chemistry science education in your classroom. So please feel free to take a note of the contact emails and get in touch with your local education coordinator, or again, feel free to get in touch with me directly and ask any questions that you might have. Thank you very much for listening and take care.